thinking about it. Okay, it's there, but then later on it comes in handy and you find that okay, you find this stuff, or you can help you connect the dots. So as problems of adult, whenever you're looking, when you're living in this world you live in, nothing goes to waste. Every single thing you see, every single thing you do matters, and it could lead you to make breakthroughs that are going to change lives. So that's the instance I'm going to add to that. That's what I'm going to add to it. So today we are going to be talking about PCB, and you all know what PCBs are, don't you?
Yeah.
I'm getting a bit concerned now. Huh? You don't know? You know what PCB is? You know? Okay, who doesn't know it?
Raise up your hand if you don't
It's
know.
going to be embarrassing. That's no, it's not. You don't know what PCBs are? Wow, that's scary.
Level 2. Raise up your hand and I'll cut it off.
That is scary. Okay, PCB, they are what they call printed circuit boards. It's like board. You know, you've done this breadboard stuff, but this time they just print it out. And basically, what it does is it reduces. You know, you can do something like this, something like this, something like this. So it shrinks everything down. The wires become parts on the copper board or whatever material they decide to use. Some of them they even use liquid now. So it's quite tricky stuff. But basically what it does is it brings everything down and reduces it down to a manageable size. That's why you have all your gadgets, your mobile phones and everything. They use PCBs, and they can range from relatively sizable ones that like the type you find in radios and all that stuff to things you use on tiny electronics. The mobile phones are quite sophisticated electronics, and yeah, they are about as sophisticated as they come right now. But they've got quite a lot of components in them. Even the cameras, they are so tiny. You guys don't know how they come about them. So, but they are sophisticated these technologies, and to print them out, you require, because they are so tiny, the human eye can barely see some of the components. That's how tiny they are. So, to print them out, you need sophisticated machines. We call them pick and place machines. And in the industry, these machines pick them and use image recognition and precision and this position to position the components accurately and solder them onto the board. And that is another tricky process. Imagine soldering something you cannot even see with your you can barely see with your naked eye. So it's quite high level stuff. So, but that is at the advanced end of PCBs anyway. So for this lecture, what we are going to be doing is introducing you to what it entails. So what happens is that he will, my partner here, that's colleague here, his name is Malik, he's an engineer, electronic engineer, so he will take you through the process of making PCBs. And one thing I would like you to have in mind is that it's basically, don't think it's rocket science, it's just basically reducing cables to tracks on a metallic plate. That's what it is. And you place the component on top of it. It's quite straightforward. So I don't want to take too much of your time because probably by 3 we should be stopping. So he will take you through the processes, and I think he's got a simple board that he can talk you through. So yeah, I can give way now, and he can take it from here. So.
Hi guys. First of all, can you hear me at the back?
Yeah.
As my name is Malik. I graduated 4 years ago in engineering. And first thing is, this is my first time I'm speaking to the audience, so if you don't understand anything, you can ask again. Or if you think I'm nervous or something, then it's normal. Anyway, let me start with the PCBs. PCBs are pronounced as printed circuit boards. The idea is like, I think Deji gave you a circuit for 5-5 timer.
Yeah.
Everybody got it?
Yeah.
Yeah, most of them got it. The level 2s have got it.
Yeah. Okay. It's a small, basically a timing device which turns on the LED and turn off the other one. So, as an engineer, you design a circuit and somebody asks you to convert it to a little device. How are you going to do it? This is where the PCBs come in. So, if you have a schematic which you did on your notepads, you want to transfer it into a CAD software with a computer-aided design. So, there's quite a few of them out there. The one we use in here is KiCad. Anybody familiar with? Yeah.
Before the end of the lesson, I'll put it on the board again. Hopefully, they will go and download it at home.
Yeah. It's like anything in industry, they have so many of them, like KiCad, Eagle, and there is a dip trace, and Spark ones. So every engineer, like, when you become engineer, you will choose one you will like. So I personally use dip trace. My relationship with the KiCad started this morning after 11. when they said, can you do? So
well, that was the one your boss recommended to you to do.
Yeah.
They made it over there.
Is dip trace, is it open source?
Dip trace is open source as long as you're only doing 2 layers. But if you're doing more than 2 layers, but for the most of the purpose, even in industry, they only use 2 layers most of the time.
Okay.
So it's up to 2 layers. So 2 layers is free. After that, you have to pay a rent
For 2 years.
2 layers. The PCBs have layers.
Okay.
Yeah. So for 2 years free. So which is okay for like even if it's for like an industry. Okay. Only 2 times you need more than 2 layers. But yeah, but all of them they work with the same thing. Like the components you have, you go and find. Let's say if I want to find a resistor, what I do is put R here. So that's all you carry on. Like if you want to find battery, you want to find capacitor or anything, you just place all the components on the screen, and then you design and you wire them up according to the schematics you have that you designed or the circuit you designed. And basically